face at all?
No.
Yeah, just wipe the one with our face on now, if you haven't already.
We're live, hopefully. We should,
Yeah, that's good.
Be here. So, yeah, hello everyone. Sorry for all the technical difficulties we've been having. Hopefully, we are now sorted and everything's good. So,
do you want to give a little introduction about yourself, Pete?
Sure. Yeah, let's do that. So, my name's Peter Champneys. I work for Autodesk as a technical consultant, mainly focusing on generative design. And we've also got another Pete with us.
Yeah.
Introduce himself.
Hi, I'm Peter Simpson. I am also a technical consultant with Autodesk, and I'm on our graduate scheme. So I graduated last year, and now I'm doing a lot of different stuff within the company. And today we're going to be focusing on generative design, like Pete said. He's going to run through a few different kind of tips and tricks on how to set it up. And if you guys have any questions and stuff, I'll be having a look at the live chat throughout. So feel free to type them in there, and then I'll try and strategically interrupt Pete when I can to try and get some of those across.
There we go. Strategic interrupting sounds good.
Yeah, I don't want to ruin your flow too much.
There we go. And yeah, if any of you are using Fusion at the moment, please do comment and let us know what you're using Fusion for. And also, if you've used generative design before, go ahead and let us know, because it'd be really interesting to know how many of you already have experience with that kind of thing. But yeah, as Pete said, what we're going to be doing today is just taking you through a generative design setup in Fusion 360 and showing you how we go about doing that, some of the things you're going to have to think about when you do a generative design setup. So what we're going to do is just go straight ahead and jump into Fusion 360. So let me sort out some of these videos. Okay, fantastic. So what we're going to be looking at today is just talking you through why we might use generative design, how we use it, and what exactly it's for. So generative design is something that I think Autodesk, if you've been around things like Autodesk University or been around Autodesk for any length of time, you'll have heard us talk quite a lot about generative design, but maybe it's something that you don't know how to get started with yourself. Maybe it's something that you're not necessarily familiar with how the process works. And I think there's a lot of people actually who don't even necessarily realize that this is something that is inside of Fusion 360 for anyone with a commercial license. So what we're going to do is we're going to today be walking through the generative design setup of one of the components in this assembly here. So you can see we've got a This is actually like a pedal box assembly on a car. So we've got an accelerator, a brake, and a clutch pedal. Hopefully we all know what those are. And when we look at a big assembly like this, we've obviously got lots of different components inside of here. And what we can see is that if we just look at one of those, if I look at just this component here, find that in our assembly. So we can see the shape that we've got here is obviously got certain functional components that connect in with other elements of the assembly. And also what we've done is we've kind of taken material away. And often what we'll be wanting to do is take material away for lightweighting purposes. So in this case, if this is a kind of subtractive manufactured component, we're deciding to add cost to our manufacturing process to take material away in this case. And in doing so, we're wanting to add value to our component. In this case, some of that value comes from lightweighting. So lightweighting is obviously something that is very valuable. You can think about for a car, for example, we can increase the performance of the vehicle by reducing the weight of the entire assembly. So, for example, we can increase the acceleration time, improve the handling, etc. But one of the reasons that lightweighting is most important is actually as everybody is having to think more and more about issues of sustainability when it comes to cars and planes especially, and we look at the question of how do we make reduce fuel consumption, or for electric vehicles, how do we increase the range, lightweighting is really, really important. So what we're going to be looking at today is how generative design can help us with a lightweighting setup for some of these components. So generative design, for those of you who haven't kind of experienced or heard it before, is essentially where instead of a human or person coming up with designs themselves, we use intelligent algorithms to come up with solutions for us. So what we do is, instead of the person going into their CAD program like Fusion 360 and modeling a solution, what we do is, instead of modeling the solution to our design problem, we set up and basically describe the problem that we're trying to solve, and then we get the software to come up with solutions for us to solve this design problem that we're trying to solve. So it's really kind of flips the traditional design process and approach on its head. So what we're going to do is show you just kind of like how that works inside of Fusion. So the first thing I'm going to do is just show you the component we're going to be working on. So we're going to be working on this pedal here, so the clutch pedal. And again, if you're familiar with Fusion 360, you'll know we've got all these different workspaces that have kind of specific tools for what you want to do. So I'm in the design workspace at the moment. This is where I've got all the kind of modeling tools, sheet metal, surface modeling, solid modeling tools to create solutions myself. So to do a generative design setup, what we need to do is drop into the generative design workspace. And this is going to give me tools for, instead of setting up and modeling a kind of solution, this is going to give me all the tools I need to describe to the software the design problem that we're trying to solve. Okay, so we've got now our assembly inside of generative design. And the first thing I want to do is basically describe what we're going to do, as we said, is describe the design problem that we're trying to solve. And the first thing I'm going to do is take us into what we call the edit model workspace. So when we use generative design, we're basically, you can see we've got the tools we need to go through generative design on the top here. And these are laid out very intuitively in this kind of like step-by-step process. So you can see we've got a kind of like guide and some learning resources. So that will turn on like a learning panel that will kind of take you step by step through the setup. This is how we set up new studies. We've already got a study created for us, and I'll talk a bit about those later on. And the next thing we have is this edit model workspace. And what this is going to let me do is create the geometry I need to describe the generative design setup. So the component that we're going to be redesigning with generative design is this clutch pedal. So the first thing I'm going to do is just find that clutch pedal as a component. So yeah, this is how I find things in Fusion, which is just if you click on something, you get this kind of dotted underwriting of the in the component tree. And I can just right click on that, and I'm just going to press remove all except selected. And that's going to do a remove operation. So a remove operation is a bit different to delete in that it appears on the timeline. So if you can use the component, you can reference it and then remove it afterwards, and you won't lose all the connections that you've added. So we've now just got the clutch pedal that we're interested in. So this is like, we've got a few of these in Fusion 360. This is a part of the workspace that is kind of disconnected from the main design workspace. So we can see if I go back into design, I haven't deleted anything in here. It's just inside my specific model editing context for generative design. Okay, so when we use generative design, what we do is we create these things called obstacle geometry and preserve geometry. And essentially, if we think about the algorithms that we use for generative design are obviously very intelligent algorithms, but they don't have the same level of intelligence as a human in that they can't just look at this object here and create alternatives. We need to give it a kind of starting point. And the way that we do that is through what we call obstacle geometry and preserve geometry. So our preserve geometry is going to be basically like the key interfaces on the design. And when we think about what needs to be preserved geometry, we want to think about, okay, how is this component going to be used? And sometimes it's helpful just to like look at this design in context, and we can see, okay, so this clutch pedal, it's obviously attached to the rest of the car and the rest of the assembly in certain points. So we can see it's hinged about this point, and we also connect on to it here. And then what I'm going to do is I'm going to be pressing my foot against this kind of paddle. And so those are the 3 points of interface with this component. So those are going to be my preserved geometry. So what we want to do is just grab those interface locations. And so when you set up a generative design study, you'll often either be taking an existing design and redesigning it, or setting something up from scratch. And if you're taking an existing design and redesigning it, you've got the advantage of having geometry already in place that you can kind of grab and make use of. So what we need to let generative design know is that the first area is, let's just check that actually. Okay, yeah, so it's actually, if we can see here, it's going to be this hole here that we're interfacing with. So what I'm going to do is go into my generative design study, and the first thing I'm going to do is just simplify this design a bit. So if you've ever used finite element analysis and simulation, we have a few tools that are kind of brought across from there that are used to just take unnecessary complex bits of geometry out of the model. And this will be, for example, you could imagine like little bits of text that are very important in terms of the final design, but aren't going to be important in terms of like an FEA simulation. So we'd want to remove those kind of little details from the model. And we have the same tools here. So if I go into modify and then I can go remove features, and then it's going to ask me to select the body that I want to remove features from, and it's going to automatically pick up different types of features. So you can see it's selected and recognized fillets, chamfers, holes, etc. So to start off with, I'm just going to get rid of all the chamfers. And if we press delete, you can see it's just got rid of those chamfers. And that just cleans up the model a bit, which makes it easier for this step of the process. So to grab this, if I get the right one, to grab this hole here, all I'm going to do is just create a sketch on this plane. And it's going to jump to that automatically, the center of that hole. And we just want to grab a bit of geometry around the outside. So this is fine for now. So the amount of geometry that you need for your preserved geometry is kind of a bit arbitrary, but essentially the less information we give generative design, the more freedom it has to come up with and be creative and come up with its own solutions. So in general, if we create a kind of less geometry for our preserve, we're going to give generative design more freedom to design things. So I'm just going to do an extrude through there. And importantly, I'm going to create a new body. And so what that means is when I go out of my edit model, when I come to select my preserved geometry, I need to select individual separate bodies. And in this case, so we need to make sure that when we create these extrude features, that we're creating a new body. So I'm going to go back into my edit model workspace. I'm going to show this. And the next object I'm going to grab, so our next kind of interface location, if I go back to generative design, is going to be this hole here at the bottom. So again, what I want to do is just use my existing shape and grab that. And one really useful way of doing this, a kind of tip, if you've got an existing model, is to use the intersect tool. So what I'm going to do is I'm again just going to go onto this face and create a sketch. Again, just connecting onto that central point of the circle automatically. And I'm going to create a kind of larger cylinder. That's this whole thing. Again, I'm going to use the other side of this to just extend that through. And I'm going to create a new body here. So we've now got this large kind of cylinder that is kind of over where we need it to be, but it hasn't got all the detail that we need. So this is where this intersect feature is really, really useful for grabbing bits of an existing model. So if I go modify, combine, these are what we call kind of Boolean operations, where we can do things like join two bodies together, we can cut one body out of another body, we can also do what we call an intersect. So my target body is going to be that big cylinder that I've just created. My tool body is going to be my existing design. And if I select intersect, what that's going to do is just keep the geometry where these two bodies are both in the same place at the same time, where they both are intersecting with each other. And I'm going to make sure to press keep tools, because if I don't press keep tools, it's going to delete all my tool geometry. And I want to keep it in this case. Press OK. You can see if we again hide our geometry, we've created this shape that's like, we've grabbed a bit of the existing geometry essentially inside of that circle. So that's again really useful tool for this kind of operation. And then the last bit of what we call preserved geometry is going to be the face here, which intersects with our the foot. So the foot is going to come and press against this object. And I'm just going to click on that face, and again, the less geometry we kind of specify here, the more freedom generative design has to come up with designs of its own. And again, I'm going to press new body. Okay. So if I come back into generative design, to out of the edit model workspace, these are the three interface locations for this design. And I can now specify these as preserved geometry. So this might look a bit strange, right? We've got these kind of three floating objects, and essentially what generative design is going to do is use intelligent algorithms to create a shape that connects these three components. So again, if I go back to and have a look at this in its existing design, we can see that this design is all the other bits of geometry beyond those three preserved locations. The purpose of those bits of geometry is to provide strength, performance, resilience to this component. And these interface locations are what allows it to perform its core functionality. And that's essentially what we're telling generative design. We're telling it these three kind of theoretical regions in space, these are what it needs to perform its core design. And so our final design needs to have this exact geometry in it. But everything else is kind of up to the software to come up with its own solution. And it's going to come up with that solution based on the same reasons why we have that geometry in the existing design. It's going to come up with solutions that are lightweight, high performing, strong, to connect these three locations. Okay, so again, a little top tip when you're using generative design is that the simpler this geometry is, the better. So I'm actually just going to go in here and get rid of this little undercut here. And this is something that we'll be able to model back in and add at the end. And I'm just going to delete those faces. Okay, so once we've created this preserved geometry, the next bit of geometry we create is called obstacle geometry. And this obstacle geometry, we've defined generative design. These are the regions our final design needs to have in order to perform its core functionality. And our obstacle geometry is going to be, we need to let generative design know that there are areas that it can't go into. And there are spaces that it needs to keep clear of geometry that it creates. So again, if I go back to this existing design and I look at my component, so all we've told generative design at the moment is that you need this bit here, you need this bit here, or this bit here, and you need this bit here. So if we told generative design to come up with solutions at the moment, there'd be nothing to stop it creating a design that had this, that had a shape like this. Maybe generative design thinks that this is the best possible solution. Now, because we have common sense, Pete's head is a little bit in the way of my screen, but that's fine. So because we have common sense, we know that's a stupid design. You can't push against, this is going to get in the way of the person's foot pushing against the pedal. going to crash into our foot plate. We're not going to be able to put our foot plate where we want it to. So this to us is really obvious that this is not what we want. But this isn't obvious to our algorithm, which doesn't have, it might be very intelligent in some senses, but it doesn't have what we would call kind of common sense. So we need to let the algorithm specifically know to stay out of certain regions when it creates these shapes. So in this case, we want to make sure that it doesn't protrude out of or through this kind of plate. And so this is what we use obstacle geometry for. If I just go back.
So, Pete, can you just quickly turn me down? Because some people said that I was too loud earlier.
Yeah, that's fine.
And then also, would you then say that it's always a good idea to keep, say, an assembly file or something open while you're going through this so that you can check some of the stuff that you're going through?
Yeah, absolutely. So when we set up generative design, what we're actually doing is, as we said, describing the design problem. And it's actually a really great exercise to go through, even if you're not doing generative design, is to really think about, okay, what is the actual design problem I'm trying to solve here? And it really forces you to kind of think through each design decision that you're going to be making. And so having your assembly model available is really, really helpful. So, I find it very helpful, at least, to kind of visualize conceptually, okay, what is this clutch pedal actually doing? Because we need to kind of dumb down the description. Like if I said to anyone here, we're making a clutch pedal, we all know what a clutch pedal is. We know what its purpose is, what its function is, and we kind of have this existing understanding of what a clutch pedal is. And when we use generative design, we have to describe to an algorithm what a clutch pedal is. And that is a much more difficult thing to do because we have to really simplify that problem to its kind of basic elements. And in this case, those basic elements are you kind of push against this bit here, this bit rotates about here and kind of pushes in here. And these kind of really simplistic descriptions are actually harder and take more kind of conceptual thought often than if you just say, okay, I know what a clutch pedal is, I know what it needs to do. So having your wider assembly model, or at least maybe even like sketching things out, just being able to visualize and conceptualize what is this object actually doing is essential. Yeah. Okay, so what we need to do, as we said, is describe these kind of obstacle regions. And we do that with exactly the same tools as we've used to create the preserved geometry. So we use just normal CAD modeling to create shapes in 3D space that are going to be our kind of obstacle keep out regions. So we spoke about the first one, which is going to be, I need to make sure that we have space to push the clutch pedal with my foot. And what I'm going to do again is just create a sketch on this plane here. And I'm just going to create like a kind of surface basically. I'm just going to select this, every element of that profile. Just going to drag this out. It doesn't really matter how far this drags out. And create that as a new body. And essentially what we're going to say to generative design is, I'm going to specify this as an obstacle region in red. And what that means is that generative design can't create any material that exists inside of this red region. So this kind of surface like this is going to do a pretty good job. So it's not going to be able to create anything that comes out of here and goes through this shape. Obviously what it could do is create a bit of geometry that went up here round the top all the way down and connected back in like this. So there's nothing to stop it at the moment doing that. So you have to be very, very careful when you create this obstacle geometry that you're the generative algorithm will solve the problem that you've given it. It won't apply any common sense. So a great example of this is you could think about something like if you wanted to design a door handle, and if you were saying, okay, what's the obstacle region for my door handle? Well, I need to make sure that my door handle doesn't interfere with the door at all. So you bring in an existing CAD model of a door and you set it as an obstacle geometry. But let's say there's like a keyhole in my door. There'd be nothing to stop generative design creating a door handle that connects in through, goes through the keyhole and connects in on the other side. Because we know, okay, that keyhole is going to be used for something and needs to be kept clear. But unless we specifically tell generative design to do that, it doesn't know. So this is where creating these obstacle geometries, when you first start going through this process, can be a bit counterintuitive. And again, this is where I think there's a lot of value actually in setting up these generative design studies, just in forcing ourselves to really think through these design problems. Okay, so we've set up one obstacle region here. We need to be really careful that we set up all the different obstacle regions that we need. So these holes that we've specified, if I hide this, we've got components that need to go through those holes. So what we need to do is tell generative design that it needs to keep that hole clear of material. And we also have something that's going to connect in and actually interface with that top face. So we need to let generative design know to keep the hole empty, but also to leave space for this interfacing component here. So that's what we're going to do next. So I'm going to go back into generative design and go into my edit mode workspace. And this kind of like connector, what we call a connector obstacle, is a really common type of obstacle region. So you could think about anything where you've got a bolt and a hole and you need to bolt into that hole. You need to leave space for the bolt inside the hole, but you need to also leave space to allow the assembly process where you're putting the bolt into the hole. And we have a specific tool to describe this that we call a connector obstacle. And this is just a kind of automated script that's going to help you quickly create these types of geometries. Again, they're the sort of thing that you're going to use all the time when you're using generative design, but you would never use in normal CAD modeling. So what it's going to ask me to do is select the start and end point of a shaft, and I'm going to select the start and end point of this component here. And then I can also specify what we call a bolt head. And this will let me specify a region in space to also keep clear, to allow, for example, if we've got a bolt head that's wider than the diameter of the shaft, this is going to allow me to put that bolt head into place and also leave space for the assembly process. And in this case, we want to create this geometry on both sides. Okay. And I'm going to do the same for this component here. I thought that I deleted this, so we'll do that again. And then I'm going to create a connector obstacle. Again, we want to leave space either side. Yes. And then we've also got some holes here. What I'm actually going to do in this case is get rid of those in our generative design study. And then I'm going to add those in at the end once I've created my geometry and got my outcome from generative design. Okay, so we've got some a very strange looking shape or series of shapes now. And what we've done is we've defined like a geometry envelope inside of which generative design now is able to come up with ideas and solutions for this clutch pedal. And we know that those solutions are going to meet our geometry requirements. They're going to have the bits of the design that we need, and they're going to stay out of the areas that we need it to stay out of. So I don't know if we've got, now's a good time to pause for any questions, Pete, or if you've been answering those as we've been going along.
Yeah, so one question that's just come in is about the main purpose of generative design, or what you see as the main purpose. So is it mostly to do with minimizing the weight, or are there other kind of purposes that you could use it for?
Yeah, that's a really, really good question. So generative design, as we said, is based at its core, it's about using algorithms to come up with solutions for us. And this is useful for a number of different reasons. One of the biggest reasons, and we'll see this shortly, is that we can come up with many, many more design possibilities than we'd be able to otherwise. So what we'll see is once we've set up this study, it's going to take me a bit of time to set it up. But once I generate these outcomes, I'm going to get maybe 100 different design possibilities that are going to be generated simultaneously in the cloud. And so what I can then do is make decisions about which design might be best. So for example, we can compare different material choices against each other. So we can say maybe if I make this component out of titanium, I can make a really, really lightweight design, maybe the lightest weight design possible, but it's going to be more expensive to manufacture than an aluminium design. So these are the kind of trade-offs that engineers have to make all the time. But usually when we make these trade-off decisions, we don't actually know what our design is going to look like, because to go through a design process takes a long time usually. We have to do all this modeling. We have to create a design that is specifically suited to a type of manufacturing method and to a material. So by using generative design to do that for us, we can make those kind of trade-off decisions about which material might be best for this purpose, taking into account things like cost, taking into account performance and those kind of things. So I think that's probably one of the biggest advantages actually of generative design, is being able to compare many more possibilities. Again, what we'll see shortly, but when we use generative design, we set what we call kind of objectives for our study. So I'm going to be setting a minimized mass objective. So I'm going to say to generative design, come up with the lightest shape you can that's still strong enough to be durable and to withstand all the forces acting on it. But we can also use generative design to come up with extremely kind of stiff structures, or to, for example, control the amount of displacement in a certain area. So we can use generative design, as we said, in this case for lightweighting, but we can use it for many more possibilities as well.
Okay, and we do also have a question about the licensing for it, which I know you're probably more qualified to talk about than I am, so I thought I'd just ask you on here.
Maybe.
It's just to do with cloud credits and also how you get those. I know we've recently potentially introduced a different way to get it as well. So
yeah, that's right. So this kind of thing always gets a little bit complicated because there's so many different types of license that you might have. So the first thing to check is that if you have a commercial license of Fusion 360, then you will have access to generative design in this drop-down menu. I'm pretty sure, I might be wrong here, so don't quote me on this, but I'm pretty sure that a personal license won't have access to generative design. I'm pretty sure this is something that is for kind of commercial licenses only. Obviously, we do have 50% off at the moment, so now is the great time to make that upgrade to commercial license if you are interested. And then, as we mentioned before, generative design is going to use Autodesk Cloud credits to as part of the process in the same way as we use them in other areas of Fusion 360, like, for example, rendering and simulation. So depending on, again, the license type that you have is going to depend how you access those cloud credits. But if you just have an individual license, so it's just yourself using Fusion 360, then one way to get cloud credits is, so whenever you come across a dialog box that asks you to use cloud credits, then there should be a buy option, and that's going to take you to your Autodesk account page. So if you go to, and Pete, you might have to help me here, is it accounts.org? What?
Yeah, I think it's accounts.autodesk.
Yeah, accounts.autodesk.com, I think. And that's where you can see, you know, which bits of software you have access to. And there's a page on there which should give you a link to buy cloud credits if you want those. We have also recently bought out the one of the things that we have inside Fusion 360 are called extensions, and these extensions are basically like specific high value additions to the main functionality of Fusion 360. So one of those is the manufacturing extension, which comes with a bunch of like high value manufacturing tools. And there's also now a generative design extension, which will give you unlimited access to generative design. So you won't have to purchase cloud credits or use this kind of consumption-based model. You just pay a single fee for the extension, and then you get access to all you can eat generative design. So there's a few different kind of ways of getting access to it. So yeah, and when I believe that this is still the case, when you get Fusion 360, you should have some cloud credits already inside your account when you join. So even if you haven't purchased cloud credits separately, it's definitely worth checking to see if you have some already. And you can use those on anything you like. So, for example, rendering or for generative design. So, okay, yeah. So there we go. A bit about the practicalities.
And then, as you can't see the chat as well, I thought I'd give you some of my highlights of stuff that people are working on. So we've got someone working on a lunar toilet for NASA, which was one of my personal favorites.
There we go.
And then also working on potentially modeling a car chassis. I didn't know if you knew if we had any history of these. I think we did one right at the beginning of when generative was Dreamcatcher and that kind of stuff, but I don't know if we have much recent work with chassis.
Yeah, definitely. I mean, a chassis is obviously quite a complex model. And like just a few kind of tips off the top of my head for something like a chassis is, we haven't got into this yet, but we're going to set something called a study synthesis. And this study synthesis is essentially when we solve this inside of generative design, how finally we kind of split the design up to understand the forces acting on it. But this study synthesis also affects the geometry that you get out the other side. So if you're working with a design like a chassis, I would for most uses, you're not going to have to really worry too much about the study synthesis. But if you're working with something like a car chassis, where if you think about the total volume of space that a chassis exists in versus the kind of thickness of elements of that chassis, that thickness is relatively small compared to the total volume, especially if you compare it to something like the design we're creating here, where the total volume eclipsed by this design space is about the same as the kind of size of the design we're going to get out. So if you're designing something like a car chassis, I definitely recommend checking out this study synthesis and maybe increasing the synthesis size. Or reducing actually to fine. Yeah. So, but yeah, those are some very cool outcomes. I saw a really amazing design actually, a few years ago at the Design Museum in London, which was a cup designed for zero gravity. So obviously I don't know much about design for zero gravity, but I imagine a toilet has a bunch of challenges associated with it. But this cup was really interesting because it used the water surface tension, so that you could actually, it would stay in the water would stay in the cup like you'd expect it to, and you could actually pour the water. So yeah, I'm very interested to hear about this toilet. So
maybe we'll need to do a guest spot one week so that we can get a full generative toilet on the screen.
There we go.
Another question is something that we're probably going to touch on a bit more next week, which is, would you take your generative outcomes directly and manufacture them? Or do you think it's a way of almost producing an inspiration for a design potentially that you would then make?
Yeah, great question. I think it's both. So if you like, a lot of the technology that we're looking at here, it very often gets connected with things like topology optimization. And if we think about like topology optimization historically, creates very theoretically optimum shapes potentially that are very crazy organic looking shapes, but they're not something that we can just directly take and manufacture. And that's something that we really have been aiming to do with generative design. And what we believe generative design is about is that it's not just inspiration. These designs are influenced to be something that we can just take and manufacture afterwards. Now, in reality, most of the time, we're going to be wanting to make some kind of edits to these designs, but those could vary, right? So we might take some of these design outputs and think, wow, that's a really interesting idea. I'm going to use that as inspiration. But what we'll hopefully see is that the designs that we get out with a few small edits here and there are pretty close to something that we can just directly take and manufacture. Cool. Okay. Any more interesting highlights?
I think that's just about it. We're up to about an hour even with our late start. So maybe we should call it a day there. Also worth noting, we are going to be doing these roughly every week, we think. So today was obviously focused on the setup. Next week, we're going to have a look at more the results side of things. So what we were just talking about, how you would take your direct result and potentially make that into an actual machinable part. And then after that, we're also contemplating going into some more creative uses for generative, as well as potentially then looking into some stuff like rendering for those creative uses. So again, if you have anything that you want to be specifically looked at in this time, feel free to put it in the comments, and then we'll have a look at those and try and adjust our time so that we can try and cover everything that you guys want.
Yeah, definitely. And we're going to be working through some of the components in this car assembly that you can see on the screen, or you could see on the screen, sorry. But if there's anything, maybe you've got some ideas of something you'd like us to have a go at, generatively designing and show you what that looks like, we'd be more than happy to do so. So please do let us know if there's anything. Maybe we could look, well, we don't want to take away from anything anyone else is doing, so maybe we'll leave the toilets to others. But if there's anything like that you want us to have a go at making and setting up with generative design, we'd love to do that. So definitely send us your suggestions, either now, or if you join us next week when we keep going with doing some generative design setups. So
perfect. I hope everybody has a good rest of the week, and hopefully we'll see you again next week.
Yeah, thanks again, everybody. And yeah, sorry about the late start today. So
yeah, apologies as well. Hopefully we've got that sorted now for next day.
Fantastic.
Right, bye bye.